Alright guys, I plugged in Chuck. I'll give you a couple more seconds to visualize until I just go. This is new, this is a little bit different, right? This is new, this is a little bit different, right? Why is it different? Where does the wording get weird? Yeah. Not the first sentence. I'd say a little bit sooner. I'd say that whole thing is new, right? The volume of the solid generated when R, what's R?
The function. Or the region,
What region?
In the first quadrant bounded by the graph of y equals 8 minus.
So where is it? Here?
It's the first and the fourth quadrant.
Right?
It's the first and the fourth.
Zoom, 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 zoom. Got it, R. What's going on with that R?
It's revolving.
It's revolving. About? Last year should have taught you, how do you show revolving?
With
And that's a circle that you should mimic in your drawing, right? Right?
Yeah. Right.
So he's revolving. How high did he go? 1, 2, 3, 4, 5, 6, 7, 8. I could have done that. Never mind. 1, 2, 4, 5, 6, 7, 8. Hey, you guys do simple math the hard way sometimes too.
But this time I
Okay, good job. Can you guys visualize the shape?
No.
Not at all?
Wait.
How about now? It's like a cup that comes to a point. I think it's no cone cup, but a little bit like concave. It's a little cup. Put stuff in. You can put like a little, and then there we go. Like a champagne glass. Anyway, taking him away. Stop, shush, focus. Okay, so I have this region being rotated about, and can I think about, right? Can I think about like a cross-sectional slice? Because volume, right? What do we think about with volume? We think about what a slice looks like, and what's a slice going to look like? Wait, what's going to be the slice of anything that's rotated? Wait, seriously?
Really?
Well, if it's rotated, exactly, right? If it's rotated about something, yes, its slice is going to be circular. So wait a minute, how do I focus? How do I find the volume again? Integral of the area, and the area is, well, that. Hold on, wait a minute, in terms of?
dx.
Does that make sense? Because the depth is dx, is changing x. So it's going to be a dx. I have no choice in that. Oh, wait, so when you rotate about a horizontal, it'll always have, coming back to it. I need area of a circle, so I have pi. I need r squared. R. Is r going to be total top to total bottom?
No.
No. Where's r going to be?
Top to the axis.
Top to the axis, right?
Yeah.
So when I'm doing r, hold on, what was on top? 8 minus
Oh, so half.
x to the 3 halves. What's on bottom? Right?
Yeah.
So technically, do I even need to rotate this as a picture? Do I even need to think about the top and the bottom at all?
No.
I could have gone back to that original region and said, hey, it's going around in a circle, and just said, sweet, radius, top, bottom, done. Wait, top, bottom, done. Subtraction of, right? 8 minus x to the 3 halves, minus 0, whatever, it's just going to be it, right? Not always the case, which is why I always show you do top minus bottom. What are my bounds? Well, I got 0 here, and I have an intersection there, so I'm just going to call him A, and I'm going to say from 0 to A, and I can't do all the work. All right, cool kids, back to our notes.
Oh, what?
Wait a minute, you have homework out, right? I spot checked it?
Yeah.
You guys all put it away. Get it out real quick. I want you to check really quickly number 18 and 42 to make sure whether or not you got it correct. I apologize, I forgot that I had that out. That's not what I want. Don't worry, that's not you. That is you, but I don't want to do that right now. Where are we at? Chapter 7? Got it. Okay. Number 18. First of all, really quickly, the answer to number 18 was
16 over 50.
8.
What?
15.
What?
Oh, wait. Yeah, I was wrong. It was wrong.
Foul.
Man, no one in Michigan got that. That's awkward. It's supposed to be 16 15. Yep. Why? Because their math is horrible. How come? Because that would be 15 15ths, right?
Yeah.
Minus, what's this one? Times 5 over 5 minus 10 15ths plus 3 over 3. Ruh-roh, that's not good. Hold on.
It was negative 1 to 1. It wasn't 0.
Thank you. Did they say first quadrant?
No, they didn't actually.
Are you sure?
I'm positive. I'll check.
Oh, because it's, one.
If it's negative 1 to 1, it'd be double that. It'd be 16 15ths. But did they say first quadrant?
It says find the volume of the solid whose base is a region closed between the curves x equals 1 minus y squared and the y-axis.
Okay, never mind. No, you guys are good. So it'd be negative 1. I was just making sure I hadn't made a mistake because I agreed with 16 15ths earlier. So guys, technically, y squared is going to hit at positive 1 and it's going to hit at negative 1. So it should have been double this because it's the same thing on either side. Or you could have thought about it as negative 1 to 1. So this is double this. So 16 15ths. 16 15ths. Good. Thank you for catching that. Okay, so keep going. Number 42, right? 43, you don't need to check this in the back of the book, but 42, the final answer should have been pi. Did you get it?
Hi, Dave. Yeah.
Alright, so how do you grade your homework really quickly? Let's come on back because if you don't have it right, struggle. It was pi. Alright, here we go. You guys wrote down all of this. Last year we called them quadric surfaces, and they were 1 sheet, 2 sheets. We were rotating hyperbolas, we were rotating parabolas, and we were rotating ellipses. This year we're rotating whatever they give us. To do what? To find the volume. How? Because when you take a two-dimensional area and you revolve it about a horizontal axis, that's all that we're going to have to worry about, a horizontal axis, the solid that's generated, you're like, wait, but it's still a two-dimensional. It's like flopping around the breeze. No. As he rotates around, as he revolves around the axis of revolution, whatever that might be, usually it's an axis like the y or the x, but it could be like y equals 10, or it could be like x equals 5. That gets interesting. It's going to generate a three-dimensional figure. Now that three-dimensional figure, as we just kind of saw a second ago, every time you revolve, you're going to have a circular cross-section. Every time you have a circular cross-section, you're going to have to use the area formula of pi r squared, which is what you saw demonstrated here. Why was it dx? Because if you think about him as in like three-dimensional discs where the depth is getting infinitesimally smaller, that's what I need. That's why I need dx. Because that's how it's being measured. And here's how it gets generalized. Generalized in a forever card. Forever number 46. True? Forever number 46. Now guys, it's totally up to you as far as whether or not to include the pictures. Some of you, it might be helpful. You don't have to do the entire thing, but it might be helpful to be drawing the little circles and then thinking about, okay, I have a circular cross-section, this is my radius, and then my depth. Maybe that's easier than just memorizing horizontal axes of revolution are always going to be dx. I don't know. Vertical axes are going to be dy. Maybe the circle helps. Maybe it doesn't. It's up to you as to whether or not you want to use it. I'll try to sketch sometimes, but technically, do you need to sketch all the time? No, but it can definitely help. Now guys, on any of the examples you've seen so far of an area being revolved, has there been space for me to stick a hand, stick a finger, stick something inside and not have it get like cut off by the spinningness?
No.
No. Why? What made it so I can't stick my hand in? If it's a solid area that's being revolved, why can't I stick my hand in?
It's solid.
It's solid, aka it's flush. What does flush mean?
Filled.
Filled?
Solid.
Really close
Like-
to.
perfectly against. Okay? If a region, and I didn't actually show you the two-dimensional region on this one, but you guys could see it in the picture up there. If you're talking about like pieces of wood that are being cut, etc., if they're flush with each other, that means it was a perfect cut because you can put them right next and they'll fit perfectly together. Same thing here. If my two-dimensional area is flush with the axis, aka it meets perfectly from A to B, from the beginning bound to the ending bound. If it is flush against, it's going to be using or having discs as cross sections. Hence why you saw the little discs in parentheses in your homework, and why you see volumes of solids with discs. That's always true when it's flush against. If it's not flush against, someone asked a second ago, why washers? Well, what are washers? Put laundry in. Nope, not that kind. Another kind. Washers. Think bolts. Bolts that you're like putting in, you're screwing into something. What do you always put between the bolt and the something that you're screwing against? A washer. What is a washer?
Circle.
Yeah, circle.
A circle thing with a hole in the middle. All right,
Oh,
anyway.
so it's like a-
So it's like a solid disc because you can feel it, right? So it has some sort of depth to it. It's just really, really thin. So a washer would be a circle with a hole in the middle. Might be a little hole, might be a big hole, but there's some sort of hole. There's some sort of hollow. We'll see that, but not right now. Discs first. Discs first. Flush against the axis or flush against the axis of revolution for whatever interval it's on. Pi r squared. Pi's can come out. Radius is going to be top curve to the bottom curve. Wait. With this whole revolution thing and like revolving around, what's always going to have to be included in figuring the radius? What's always going to have to be included in figuring out the radius? This is the radius, right guys? Pi r squared. Pi r squared. What's always going to be included? The function and the axis, right? The function and the axis. But wait, that's y equals 0, not all the time. That's x equals 0, not all the time. Wait, what? What if I move this over here? Stink. It's a different line than y equals 0. Let's move on. This one's cool, but for sake of time, I'll show you tomorrow. Remind me, come back. So, how do we do it? How do we visualize it? It's up to you as to whether you want to draw it or whether you just want to visualize, whether you just want to plug in. Same thing, right? Drawing, visualizing. Anyway, I guess not. Whether you want to draw, whether you want to just visualize, or whether you just want to solve. There we go. There are 3 options. Is it flush against the axis that it's revolving around?
Yeah.
Good. So it's a disc,
Yes.
Disc.
right?
So you can't stick your.
Why could I say? No, he's right. You can't. Why would I say that's the radius? Because what's going on,
Circle.
right?
Yeah.
It's coming around, and then this is going to form the radius of my disc. Are we track-locking? Okay, what's it in terms of? First of all, I need integration, right?
Yeah.
And more specifically, since it's a volume, I need integration of the area formula. Area formula, it's revolving is pi.
Top.
What's my orientation? dx. Why? You can memorize it's a horizontal axis, or you can think about it. The depth is represented by dx, and that's getting infinitesimally skinnier, right? Integration, making it infinitesimally thin, and then accumulating them across the whole for the boundaries that you give it. Okay, dx. I have my integration. I have my orientation. I need my intersection. What's going on? Well, not really intersection this time, but what are my bounds? Oh my goodness, that's so easy. Okay, now what? And technically, even though you're like, that's lame, technically minus what?
0.
Why? Because what's the bottom of the radius? The top is the curve and the bottom is the line? Good. How could you solve it? Hopefully I can have full faith you can solve it, right? Real quick question, Nico.
Will it always be revolving around the axis?
It has to always be revolving around an axis, or else it's not true revolution. Does that make sense?
But can it revolve around like y equals 4 or something?
Oh yeah, we'll get there. But that's why I'm always showing the minus, because what if it was shifted up 4, then it'd be revolving around. The heights of the parabola would say something like 10, but it's still between like 10 and 4, which would be different. I made up 10. That has nothing to do with this problem. I apologize. What's different?
Washer. It's a washer.
There's like a,
Okay, you read the word washer. Look at the graph. What's different? It's flushing. No, it's not.
Flush against y equals x.
So what's it look like?
It's got a hole in it.
Oh, it's stuck. Oh, that's okay. That's revolving, but what else is revolving? Right? Then I have this. And then what's going on the inside? Could I stick my hand in? Yep, because it's the best way for me to show it right now without other techniques. It's going to have a hollow region, right? Wait. So, what's my cross-sectional slice? Is it still a circle? Mm-hmm. Still a circle. But what? It's going to have a solid region. Oh, man, this is nasty. I apologize. I've been doing pretty good up until now. It's going to have a solid region, but it's also going to have a hollow region. It's going to be a washer. Ugh, that's disgusting. I apologize. That's just gross. Let's just take it away. Okay, let's try again. Right? That's a little better. Going to have my washer. Is he still going to have a depth? Yeah, he's still going to have a depth. He's still going to have a depth of dx, right? But he's going to be hollow on the inside because I didn't stick my hand in. Now, how do we actually do that? I'm introducing something, but here's how we actually do it. Volume equals pi r squared weight. When I was doing area between curves, I did the integral of one whole function to the axis, do the whole thing, minus the integral of the other. Because whenever I take an integral, it goes from whatever I give it, minus all the way down to the axis. That's just how integration works. It goes from a curve down to an axis. Why am I saying down? Because it's horizontal. I need a dx. Here's the problem though, kiddos. I'm not going to say, ooh, subtract the two, because it's not going to work because I'm plugging into another formula. But what I can say is subtract the upper and pretend as though he was a solid, which he's 2 minus x squared, pi, 2 minus x squared, technically minus 0 squared, from 0 to 1. Minus the other one from 0 to 1.
Can't you put it in the same?
Nope. Why not? Integration works by going from whatever you put in all the way down to the axis. So if I say this minus this, it'll take that entire minus that entire, but it wouldn't appropriately plug it into the squared function. So what I need to do, in essence, is basically think about, what if it was solid, which is ultimately what I'm doing here. And what if I wanted to subtract would this minus that equal that? If you were doing this in woodshop, wouldn't you make the entire first and then you would go digging out the other? Yeah. You'd have to have a big, nice block, right? You'd have to, first of all, maybe put it in the spinner. I don't even know what it's called. What's it called, the spinnery thing? Where you can shave it off? Yeah, I know. I'm not in woodshop. I didn't have that cool stuff in my high school. We had
A screwdriver.
wire?
A hammer.
I don't even know what was opposite choir TA. Anyway, what else? What's it called? Where you can spin and then you can lathe. There you go.
Router.
You might do that first, but then you would have to go burrowing in to get that out, right? It's the same thing in calculus. You would have to go ahead and think about the entire whole thing, and this is what we're going to see tomorrow and talk more about with washers. The whole minus the hollow. What? You have to do pi r squared for the whole minus pi r squared for the hollow. Booyah, that's a washer. Kiddos, we'll see you tomorrow. We have 30 seconds. Ooh, I have more time. Wait, I have more time. I have 25 seconds. 20 seconds. What would we do? Why? Because we have to go from the curve to the axis and we have to look at it and say, aw, stink. What's his depth? So is this equation good the way it is? Nope, I would need to say x is equal to y minus 3 all divided by negative 2, and I didn't need to do volume equals dy. Alright, cool kids. Get out of here. Homework is technically due on Thursday, but oh my goodness, you are so capable. Guys, the AP is the AP and the test review. So we'll be doing some FRQs together, and we'll be practicing with it. Don't finish it all tonight. Bye.